everyone, I'm Teacher Bochen from Kangaroo Study and welcome back to our YouTube channel. Now, in this video, we're going to discuss this interesting question from NMOS 2024, Round 1, Question 28. So, this testing us on the half model. So, without further ado, let us take a look at the question together. Now, in the question, it says that in the diagram below, DAF is a straight line. So, let's check point D, A, and F. These are on the same straight line here. Now, ABCD is a parallelogram. Let's check ABCD. This forms the parallelogram. So, CF and AB, they are intersecting at point E. So, let's check. The line CF is here, AB is here. The intersection point is E. Now, the area of the triangle ADE is 10 cm squared. ADE, this triangle is here. So they want us to find area of the triangle BF in cm squared. BF is just one label with the question mark. So everyone looking at the question, can you tell me what are the key information here? The first one is that ABCD is not just any quadrilateral. This special is a parallelogram. So let's label it here. What's the other key information? We can see the area of the triangle AD is 10 cm squared. So let's label this part as well. So now looking at the question, we're going to see that many triangles in the figure. First, we have the triangle ADE, which we already know the area. Of course, we also have the triangle they're asking. This is the triangle BF. Now my question for you is, how about the other triangle? Do we know about area of triangle CDE? No, we do not know about this. How about the triangle BCE? We can see that this one also cannot find. And how about the triangle AEF? This one, the area we also do not know. So now it's only about the triangle ADE and the triangle BF. Of course, we have to find the relationship between these two triangles. So in order to do those, let's take a look at that example first. Now, suppose we have a parallelogram ABCD. Let's connect the diagonal BD. So we get this shaded triangle BCD. So let's say now I'm asking you, what's the relationship between the triangle BCD and the area of the parallelogram ABCD? Right, we can see this is a very easy question because the shaded triangle BCD and the unshaded triangle ABD, these two are identical to each other. So the shaded and unshaded are equal to each other. Of course, if we compare the shaded to the whole figure, we can see this is just half of the figure here. So of course, for the same question, we can also explain it from the perspective of the area formula. So let me ask you everyone, how do we calculate area of a triangle? We can find this by using the base times the height divided by 2. So we say area of a triangle is base times height divided by 2. So for the shaded triangle BCD, suppose we take BC as the base. Now everyone, how do we draw the height? We can see that now to draw the height, you can just start from the remaining vertex, which is point D. So we draw a line that's perpendicular to the base. So this one is what we call the height. So we get the base and the height times together, divided by 2. It will give us area of the triangle. Now my next question for you is, how do we find area of the parallelogram? Parallelogram is just the base times the height. Now we're going to realize that in the figure, the base of the triangle is also the base of the parallelogram. And then we can see the height of the triangle is also the height of the parallelogram. So they share the same base and the same height. The triangle we have to divide by 2. The parallelogram we do not need to divide by 2. Of course, the relationship between them is half. And now let's change the question a little bit. Suppose now instead of having the point at D, now let's shift it from D to E. So we get this triangle BCE. Now I'm asking, what's the relationship between the triangle BCE and the parallelogram ABCD? We can see that this question, compared to just now, we cannot find it directly. So what we can do is that we can cut the figure here into something that we already know. So suppose we cut it here. We are going to get two parallelograms here. So let's look at the parallelograms on the left. The unshaded triangle and the shaded triangle, they are the same. So for the parallelogram on the right, we are also going to realize that the unshaded triangle and the shaded triangle, they are the same as each other. So we know that now when we combine them together, the shaded compared to the unshaded, they are equal to each other. So of course, if you compare the unshaded to the whole figure, this will be half of the whole figure. So now knowing that the shaded is also half, my question for you is, can we also explain using the area formula? So let's check. The area formula is base times height divided by 2. Now in this figure, this is the shaded triangle BCE. So let's label the base BC. Now how do we draw the height? We can see that now we have to start from the point E, draw a line that's perpendicular to the base. So let's draw it. This is the height. So we have the base times the height divided by 2 give us area of the triangle. Now everyone, how about the parallelogram? We can see that parallelogram, we have to do base times the height. So again, we are going to realize that they share the same base and the same height. Of course, the area of the triangle is half of the parallelogram here. Now, for the same figure, suppose we rotate the figure. Let's observe what's going to happen. Let's say we rotate it into this direction. Now, I'm asking you, what about the shaded compared to area of the whole figure? We can see that this is also half of the whole figure, because it's still the same triangle and the same parallelogram. It doesn't matter what orientation this parallelogram is in. Now, let's say if we rotate the figure again. So now the triangle is upside down. So let me ask you, the area of the triangle compared to area of the parallelogram, what's the relationship between them, everyone? This is also half of the parallelogram. So again, we know that this one, this is the base, this is the height. So base times height divided by 2. And then the parallelogram is just the base times the height. So of course, this is half of the figure. So then we can realize that no matter what orientation this parallelogram is in, this is always a half as long as the base of the triangle is on one side of the parallelogram and this vertex is on the opposite side. So now knowing this, let's make it to be more challenging. Suppose for the parallelogram ABCD, instead of having the point E on the line AD, let's put it on the extension line of DA. So now I'm asking you, what's the relationship between the triangle BCE and the parallelogram ABCD? So this time around, we can see that it's difficult to do the cutting method. Of course, we can also think about it from the area formula perspective. So for the triangle, we know that area is base times height divided by 2. So looking at the figure, again we choose the BC as the base. Now my question for you is, how can we draw the height? We know that we must start from the point E. But now the question is that if we draw a line that's vertical, and we're going to realize this is not on the base BC. So everyone, what we can do here is that we can first extend the base, we extend the line CB. So then we can draw the height. This is the height of the triangle. So that for an obtuse triangle, when we try to draw the height, this will be outside the triangle here. That's something that we can take note. So again, we have the base times the height divided by 2 give us area of the triangle. How about the parallelogram? Parallelogram is base times height. So we are going to realize, everyone, they still share the same base. The base is BC. Now how about the height? And you can see that for parallelogram, we can draw the height this way. And compared to the height of the triangle, we can see that these two, they are exactly the same. So you can see that the triangle on this one must divide by 2. So then we know the area of the triangle, this is half of the parallelogram. Now, knowing this, let's solve our question here. So in this question, how do we make use of what we have just learned? So we are going to realize just now is always about what shapes? It's about the triangles and parallelogram. And we're going to realize in this question we also have a parallelogram. So let's locate the parallelogram first. A, B, C, D. And we can see that within the parallelogram, we also have a triangle where the base is on one side of the parallelogram. The vertex is on the opposite side. So this is the triangle CDE. Of course, we know this is half of the parallelogram. Let's write it down here. Now, my question is, how about the remaining part of the parallelogram? If this triangle is half, now the remaining it must also be half. So we can see the BCE plus this triangle, which area equals to 10. So it's also half of the parallelogram ABCD. Now, of course, if we want to establish the relationship with the triangle BF, we have to link this to the parallelogram as well. So let's check. For the triangle BF, can we link this to the parallelogram directly? We're going to realize that this is not possible. Of course, then we have to choose a triangle that contains the BF here. We can see that the triangle ABF contains the triangle BF, but triangle ABF, if we compare it to the parallelogram, we're going to realize it's very hard to find the relationship between them. So then we can see there's another triangle that contains BF. This is the triangle BCF, everyone. What's the relationship between BCF and ABCD, everyone? We are going to realize now they share the same base. Can you see that? They share the base BC. And then this vertex F is also on the extension line of DA. Is on the opposite side. So then we know that this triangle BCF is half of the parallelogram ABCD. So then let's separate it into the triangle BF and the triangle BCE. These two added together equal to half of the parallelogram ABCD. Now everyone, we can notice something that's very interesting. Can you see that? Here we have BCE and BCE. And we also have ABCD and ABCD. These two are also the same. So how about the remaining part? 10 and triangle BF. Of course, these two are also the same. So we can find the area of the triangle BF. This is just 10 cm squared. We can get our answer here. So now let's do a summary for this question. So in today we have learned about the parallelograms. We have the one that's just connect the diagonal. And then we can shift the point from D to E. Or we can also shift it onto the extension line of DA. Now, what's the relationship between the shaded and the total, everyone? Yes, the shaded and the total, they are half. So this is what we call the half model. And let's summarize on the characteristics of the half model in the parallelogram. So we are going to realize that the base of the triangle, this is always on one side of the parallelogram. Now my question is, how about the remaining vertex? Where can we find it? Yes, this is on the opposite side of the parallelogram. So if this is the case, then the triangle that we can form is always half of the parallelogram. Now, knowing this, let's try the practice question. After you solve it, you can post your answer in the comment section. So, I hope that you have enjoyed our video. If you want to know more about activities in our center, make sure to scan the QR code and join our WhatsApp group here. So, I'll see you in the next video. And of course, if you like our videos, make sure to hit the like button and subscribe to our channel. Until the next time, bye bye.